Hi, I'm Tyler Folse. I'm a nuclear engineer with a little over 10 years of experience in the commercial nuclear power industry, from engineering to operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge. Today we're going to be looking at a heavily requested mod to Minecraft called NUCLEARCRAFT. I don't claim to be an expert on Minecraft. I know of it, but I've never really played it very much, and I'm not at all familiar with this mod, but today we're going to be watching a video called I Survived 100 Days as a Nuclear Engineer in a Fallout Bunker Vault in Hardcore Minecraft. That is a mouthful. I can say I survived well over 100 days as a nuclear engineer in real life, but let's check it out.
100 days as a nuclear engineer in a NUCLEARCRAFT Fallout Bunker Vault. The surface is no longer safe, and we won't be able to go above ground for the next 100 days.
Surface no longer safe, huh? Probably some kind of crazy nuclear war of doom and death and destruction and stuff.
So our mission will be to quickly build an underground bunker with enough food, power, and safety measures to keep us safe from the radiation on the surface and the radiation from our reactors.
You should never design a reactor that you can't protect yourself from the radiation pit. Putting shielding around your reactor should be your first priority.
But on the start of this beautiful day, I have none of those worries on my mind. I'm headed to class because I'm about to graduate and officially start my life as a nuclear engineer. I want to spend my life showing everyone that nuclear science is something that shouldn't be feared. And, in fact, it can save the world from pollution.
Amen, brother. I remember that day, all wide-eyed, first graduating from college, ready to take on the world. I went straight into working for a nuclear power plant myself after graduating from Georgia Tech. It was exciting to finally put my knowledge to use, put my skills to use, and of course continuing to learn, because learning from what you do in college versus what you actually do in the real world, there's quite a big difference. Also, I was excited to have been done with college, because college was extremely difficult, so I can relate. So far, this is super accurate.
And
what? Nuclear explosion?
There's a nuclear explosion right behind me.
That is an immensely weak nuclear explosion to be that close for the fireball and for it to not expand and shred you with a shockwave. That might be a bit much for the game to handle, though. Who knows?
You know what? On second thought, instead of walking, I think I'll take the subway.
It's just deleting the grass. Nuclear bombs only affect grass at that distance. That's awesome.
The nuclear explosion means that we cannot...
So there's a little ticker there. You probably can't see that on the actual video because it's paused and it's got the various YouTube things, but it says 51 femtorads per T. I did just look, and T is 0.05 seconds. A tick is that long in Minecraft. And femto is 10 to the minus 15th. And a rad is a unit of absorbed dose, what the body actually absorbs from radiation. And a rad is a pretty big unit, so most times you're going to see it in micro or millirads, but femtorads is super, super small, so he's getting probably less than background. I mean, granted, a tick is pretty small, is a very small unit of time. I'm used to seeing per minute rather than per tick, but that's a very small unit, so he's probably fine. And rads is not actually the final dose because it doesn't discriminate. And by final dose, I mean that takes into account what type of radiation it is. For gammas, 1 rad equals 1 rem, and a ren, you can think of the equivalent for what it does to humans specifically, and it's multiplied by what is known as a quality factor, which, because different types of ionizing radiation can cause more or less damage to a cell depending on what it is and how much energy it transfers to the DNA strands. That's how radiation attacks the body. It hits your DNA strands and can cause mutations, which can lead to cancer, or if it's just a very high dose by itself, can lead to burns, vomiting, acute radiation poisoning, and probably one of the most horrible, horrible ways to die is how it affects you. Right now, this dose, not concerned about it as of right now, which is he's just going down into the subway. I wouldn't expect there to be much unless the subway happened to be near like a natural radon deposit or something like that that exists in the Earth's crust. But subways aren't that deep, typically. And you get a sense of what's deadly in terms of rads. So assuming just gamma, which has the lowest quality factor, so this would actually be a low ball, 1,000 rads or 1,000 rem is certain death. 400 to 500 is about a 50-50 shot. As little as 200 has the potential to be deadly, but it probably won't be, especially with... So right now he's fine. Let's see if he stays that way. It's only day one after all.
This crystal cave full of gold, emeralds, and yes, these diamonds.
All right, green cave crystal. All right, okay, hey. In so many video games I've seen, that has been uranium, but no, it's a green cave fist crystal. He mentioned emeralds, so hey, actual green rocks that are not radioactive, or at least no more radioactive than any other colored crystals, which isn't very much, but still, it's not uranium. Uranium just looks like any other old shiny metal. But we'll see what it looks like in the game shortly, I'm assuming.
Such as this thorium vein, which is the real nuclear future of humanity in my...
All right, we found some thorium ore. Hey, it's just looks like some little brownish, grayish, metally substance, which is what it looks like. That's what a lot of those super heavy metals look like in real life. So, hey, props to the NUCLEARCRAFT modders for not making it a sickeningly green glow. I like that this guy mentioned about it being the real future. A lot of people really do get behind thorium, and I would love to see more thorium nuclear power plants. That isn't to say uranium ones aren't safe. It really just, there's a whole bunch of other design considerations, such as what type of containment building, what type of safety systems you have, how many of them, how many redundant backup systems you have for all of the above, how well you train your reactor operators so they actually know what they're doing. And you can make a safe or an unsafe thorium reactor. You can make a safe or unsafe uranium reactor. But I would like to see some thorium reactors too.
And of course, uranium, the scary one.
That one, let's see. It's looking pretty metally. I mean, I'm seeing a bit of a green tint, but I think that's just his colored pickaxe and maybe him shining the light on there for him harvesting it. So it actually looks very similar to the thorium, which is kind of true in real life as well. So, hey. Refer to uranium as the scary one. I think he's alluding to that you can use uranium to make nuclear weapons, whereas you can't actually make thorium into nuclear weapons. It's just like any other tool in real life. It can be scary, or it can be a wonderful, beautiful thing to drive human progress, and just depends how you use it. Just like that fun little glowy pickaxe he's got right there. It can be used to harvest cool ore to make nuclear power plants, or you can use it to smash someone in the face with it.
We start to get into the nuclear element, as we now have enough thorium to make a thorium block.
Okay, making a thorium block. So looks like he's just combining thorium by itself and not really doing any... So yeah, just making a block. It looks like he's just using materials to make a block, because thorium... You don't have to enrich it. That is one advantage of thorium, is you can use straight thorium. Now, there are nuclear reactor designs, such as the CANDU reactor, that you don't have to enrich the uranium, but you would have to enrich the water from regular water into heavy water, which uses deuterium or hydrogen-2 as opposed to regular hydrogen-1 that exists in normal H2O water. So that's your trade-off for uranium, but that is a real advantage of thorium. There's no enrichments required.
And we'll be using this by making some decay generators, which is the very first step in NUCLEARCRAFT.
Decay generators. Not sure what that means in the game. There are types of generators, RTGs, or a radioisotope thermoelectric generator, which just uses decay to provide a very small amount of electricity, but over a very long period of time. These things can be used in space probes. It can also be used in lights, sensors, vanes that are in remote areas that you don't want people to go out, have to change them out, like in the Arctic Circle. Things that don't use very much electricity, because space probes really don't use much electricity, but you don't want anyone to have to go up and fly a space shuttle to catch up to the space probe and change it out, or someone to go on a remote Arctic expedition to do it. So that's what that's what an RTG does. I don't know if that's what they mean by decay generator in the game, but you can generate electricity, a very small amount, just with radioactive decay in real life.
I really do not have any power.
Yeah, decay generators aren't going to generate much electricity. And I've noticed, again, you can't see it, that it's paused. He's at 25 microrads per tick. So he's at the threshold, and remember, a tick is 0.05 seconds. So he's well above the threshold that he's going to need to have you would have to have a proper radiological briefing in real life to do this sort of job. Obviously, you wouldn't mod that as part of the game. And especially this game, it looks like a Soul Survivor post-apocalypse type scenario if he's trying to survive under a city that got hit by a nuclear weapon. That's when the dose you're going to get, if you hang around there for too long, there could be some consequences.
I'm going to rearrange the uranium so that as many surfaces of the DG are touching radioactive sources. By doing this, they'll be giving us the highest amount of angry juice possible.
Highest amount of angry juice? What? I've never heard radiation referred to as angry juice. Might have to remember that one.
So we still have quite a ways to go.
Oh, it is. Maybe I spoke too soon. It looks like these blocks of uranium have that little bit of glow. It's more of a muted than the sickly green glow that you see in, say, The Simpsons. But yeah, I guess they got it for gameplay purposes. They got to make uranium look different than thorium.
And by adding boron to our steel, we're going to be making ferroboron, the next step in tough alloy production.
Wonder if he's going to use the boron to make control rods. Wonder if that's part of the game. That'd be kind of cool to see.
We set up all the casing for the back wall, and then we set up our controller right here up front. So
casing looks like the pressure vessel for the nuclear reactor, and then a controller. Just looks like a little box there. So he's going to be operating the reactor right next to it. To give you a sense of where the control room is in real life, it's not even in the reactor containment building. Completely remote. It's in what's known as the auxiliary building, specifically the electrical auxiliary building is what a lot of nuclear power plants call it, including the one that I worked at. You wouldn't want people in the reactor containment building in case, what if something happens there? You wouldn't want the control room to be there. You can be in the containment building at power, as long as you don't go into what is known as the bioshield, or the primary shield wall, actually going into right by the reactor coolant system, which is super radioactive. Unless that's like an automatic drone controller or something like that, you don't want to be right next to this thing.
Quickly access it. Next, we're going to work on the sides, which is easy. It just takes a little more casing. But because I want you guys to have a little show, I'm going to make it transparent casing. This way, you'll be able to see inside of the reactor.
That would actually be really cool if you could see inside the reactor as you're starting it up. You can actually see in certain smaller reactors, like a research reactor. So standing at the top of that railing right there, you're at a safe distance, even while starting up the reactor. But at one, you're going to produce power at scale. No. But this type of reactor doesn't even need a confinement building, just because or containment building. It does have a confinement building, but not a pressurized containment building, simply because it's designed in such a way that a crazy accident is just impossible because there's that little energy in the machine. So you don't need all of the fancy defenses, if you will, that a commercial nuclear power plant has. By the way, you can have nuclear reactors in real life that kind of look like Minecraft. stuff, just an arrangement of graphite squares, because graphite is a moderator to slow down neutrons so they can cause fissions. But Chicago Pile 1 was one such design like this. It only produced half a watt. So, not practical. But as far as a proof of concept, it was a necessary step towards the development of nuclear power.
But soon, we have 6 cells and 4 graphite blocks, which boost the efficiency of the cells.
So cells is referring to the actual fuel assemblies, is what they're normally called in the industry, that actually contain the fuel, whether it's uranium or thorium or plutonium, what have you. They're arranged in assemblies. And graphite, as I said earlier, says boosts the efficiency. That means slows down the neutrons, causes more fissions. Chernobyl was one such reactor in real life that was a power reactor that actually used graphite. Using graphite by itself isn't what caused the accident. There's a whole bunch of other bad things they did that ultimately led to the accident, but graphite has been used on reactors at scale too, unlike just the research reactors.
You might recognize my classic reactor build. There's the lapis coolers, which must be touching a cell and a wall of the reactor, will go in between each cell on the top level and the bottom level. Finally, we move on to the tin coolers, which...
Lapis coolers and tin coolers. I mean, I guess he doesn't really have a reactor coolant system, so I guess you're using in terms of being a liquid or a gas, that's normally what it is in real life, but he's using solids, using lapis, which is a mineral, and tin, which is a metal. That's okay. I've never heard of anything like that.
A reactor port to the top, because this is where we're going to draw the power out of the reactor.
Okay, a port, like a plug. A reactor plug. So we're not using a steam cycle at all in this case. We're using solid coolants, solid state coolants, and basically a plug to plug into a reactor. No steam cycle, no turbine, no generator, just you plug it in there. That's hilarious. I love it.
A fission reactor runs on nuclear pellets, which need to be made out of enriched nuclear materials.
Okay, so when he made the cells, I guess I misspoke. The cells were just probably the things that housed it. Because yes, pellets are what it's called in real life. Having to translate in my head the Minecraft terminology versus the real terminology.
This again is a fairly basic machine made out of basic panels, and once we have it set up, we can put thorium in here to enrich it.
So isotope separator is... So how it works in real life is you take uranium, you convert it into a gas. Uranium hexafluoride is a gas, and you sift it to. You can run it through centrifuges, or you can run it through diffusers. Those are the two main ways of doing it to separate out the uranium-235 and the uranium-238. Naturally, you have way less than 1% uranium-235, and most of it's 238. But to make a nuclear reactor, you're going to want it in the 3 to 5% range in order to do that. You shouldn't need to enrich thorium, though. Maybe he's referring to mixing in thorium with plutonium or something like that, because thorium by itself won't actually fission. It'll fission with a fast neutron, which most reactors don't operate in that spectrum. I'm going to assume the one he's designing doesn't. It can absorb neutrons, thorium-232, and turn into uranium-233 after a few decay chains. That's how you can use thorium. So you don't actually. So when you say you make a thorium reactor, it's a bit of an indirect way, but you do need a little bit. It's usually plutonium-239 that you work with to synthesize uranium-233 from thorium-232.
Thorium dust. Day 18, and we get
thorium dust. Okay.
This thorium-232, the isotope that we need to make thorium-bred uranium fuel.
Okay, yeah, he's right in saying thorium-bred uranium fuel, which, you get the uranium-233. Okay, that part's right. Not sure about the dust. Nothing wrong with making it dust. You could conceivably make it into fuel. Maybe you have to get it to dust first and then before making pellets, but dust is just kind of hard to work with. You also don't want to inhale said dust of anything radioactive, because alpha particles, I mentioned quality factor earlier, they're 20 times worse than, say, gammas, especially if you take them inside. Normally, they won't penetrate the skin, though you still don't want to hang out near it. But if you inhale it, alpha sources such as thorium and uranium can be pretty hazardous to your health.
AKA TBU fuel. Speaking of thorium, this is just me going on like a little rant here, but the future of nuclear power in the real world has to be based on thorium-based molten salt reactor. Case in point, a huge part of thorium just decays away into lead like it does in NUCLEARCRAFT. 0 rads. Also, thorium is very plentiful all the world over. It's a safe fuel to stop climate change.
Okay, maybe looking at a bit too much into the game here, but thorium, again, I'd love to see more of it. I actually did more of an in-depth reaction video on thorium to one of Sam O'Nella's videos where he talked about thorium. Thorium, first off, you don't need molten salt reactors to have thorium specifically. You don't. You can. That's one particular design, but to say you need thorium or molten salt reactors as an only thing, man, as an engineer, I don't like pigeonhole myself. Just think of it as an investment portfolio, putting all your money in one thing. Just, no. Generally not a good idea. So I could see it playing a role along with other types of thorium reactors, other types of uranium reactors, and to see a glorious nuclear energy future with all kinds of wonderful nuclear technology to help us fight climate change, meet energy demand, reduce dependency on countries that we'd rather not import from. To have one particular type of reactor do it, it's limiting. And also on molten salt reactors, they do have some characteristics from they're not with their disadvantages too, like having to synthesize the molten salt.
I feel like I have to state my political views here because they've come into question recently, I guess.
Nuclear power should never be a political thing. It should be a function of science, technology, engineering, development and production, and investment. Politicians serve no purpose in the development of this sort of technology, but it's a shame that it has come to that, though.
And we do get a decent 1100 RF per tick. And now we're cooking with gas. Well, I mean, technically we're cooking with microwaves, but hey, even better. We go from this half-powered machine, take out the DG, and directly plug it into the reactor and go straight to full power, boys. In fact, with all this bonus power, we can really start to add in some of those speed upgrades.
Now that would be so cool to just plug basically a nuclear brick that you can just plug into, no steam cycle, no nothing, and then adding these magical speed upgrades to ×2 your production of whatever it is you've plugged it into. That would be so crazy and so cool.
Hear that?
What is this? It even says nuclear blast. Okay, what kind of weak sauce nuke is this? No thermal pulse, no shockwaves destroying those buildings. It's a very skinny mushroom cloud that, given how small that area is, probably wouldn't even produce mushroom cloud in real life. Yeah, that is just silly.
To cure my radiation, I'm gonna need Radaway, which...
Alright, a couple of things. So Radaway, clearly a reference to the Fallout game franchise. Nothing like that exists in real life, though. Also, curing radiation, not a thing. Radiation, it's like getting sunburn. There's stuff you can do to treat the symptoms, like putting aloe on the burn, but nothing is going to basically negate the fact that you stood in the sun for a while and got sunburn. Same is true with ionizing radiation. That's not a thing. Now, there are treatments. Mainly it's for contamination, so it's about getting decon, which can be just forms of shower, as well as being essentially scanning yourself with detectors to make sure you got it all. Internal contamination, there are various medicines you can take to prevent uptake in certain parts of the body, like potassium iodine tablets to prevent iodine 131 from being absorbed by your thyroids, and because you absorb non-radioactive iodine instead, is what those tablets do. And there are other types of treatments that can be used to flush the contamination out of your body to help you poop it out, basically. Nothing cures radiation. That's not a thing. Not even sure how Radaway is supposed to work in the Fallout game franchise, and clearly that's what this mod took their inspiration from.
I see that it does a 0.01 rad resistance. That's just not good enough.
Yeah, you're going to need something a lot stronger than that. You're in millirads per tick, which is several hundred millirads per second. No. This would be at 500 rads per hour, you're going to be looking at a sign that looks something like this. Yeah, escort, briefing. I've never seen anyone go in these sort of zones. And there's a reason why it's the same shape as a stop sign, because you do not want to go there.
We might actually live through this whole thing without growing a third mutated arm.
I don't know if that's a mechanic for the game or not. He clearly said that in jest, but you're not going to grow any extra limbs in real life from radiation poisoning. In fact, you're probably more likely to lose limbs, especially with just with the close contact with a bad source, burns. That's a more likely scenario right there. But it's more of about damaging your internal organs. So you're probably not gonna lose one anyway, unless you just had a very high dose targeted to one specific spot of the body. The whole extra limbs, not a thing.
Reactor. I very, very carefully boot up the reactor, and it quickly starts to redline. We are producing over double the power, but this is dangerous to say the least.
So really starting up a reactor is a pretty involved process. Even little ones, like a research reactor, it's way easier to start up one of those than a commercial nuclear reactor just because of all the administrative processes and starting up the massive secondary plant, turbines, feed water pumps, circulating water pumps, just because it's a much bigger facility. Even a small one, you're not going to start it up that quick.
With this overheating, this means I need to manually work the control rods and keep the reactor from going critical. And
manually work the control rods. That's a bad design when you have to manually work the control rods. So control rods for a temperature excursion would automatically step themselves in to correct the issue. It's a nice thing about modern reactor design is it can protect itself. And it becomes too much, the reactor automatically shuts itself down. All the control rods fall in, shutting down the reactor in a couple of seconds. Critical means the reactor is on. When you start it up, it's critical. That's all what critical means. Critical doesn't mean it's about to explode or cause some unfortunate reactivity excursion. No. Critical means steady state, actually. The amount of fissions are constant. It's actually the most calm condition that a reactor can be in is critical. Subcritical, you're lowering power. You can also refer to a reactor as subcritical if it's fully shut down. And supercritical is you're raising power. The scary one is prompt critical, which refers to a massive ramp rate in power that goes up by many thousands of a percent per second, such as what happened in Chernobyl. But there are so many measures in a modern reactor to prevent you from one of that. One being the control rod automatic insertion system and reactor trip system that I just talked about.
Radiation shielding. That means beryllium. And that means we need a rock crusher.
One other thing I just wanted to point out was the whole idea of making a reactor, getting it operated before putting a bunch of shielding up is literally putting the cart before the horse. You have all your shielding, all of your containment structures, all of that built long before you even have nuclear fuel on site. The Nuclear Regulatory Commission won't let you do that.
I open up a nuclear reactor. Yeah, don't try this at home, kids.
If you're going to do any modifications to cooling, shielding, turn off the reactor first. Also, glowstone. Cursory search on Minecraft Wiki just says it emits light, but doesn't really have any inherent shielding properties one way or the other. I actually would have thought, just knowing what I hear about depictions of nuclear in video games and media, you would think it would be radioactive, but it's actually not. Who knew?
I then make a tough alloy helmet and add the shielding to protect the best tool I have, my brain.
This is just what's so baffling to me, is that, so he's got all these exotic materials, all this exotic fuel that he made, and the tech tree, it's like heavy radiation shielding is like the end of it. It's like Dude, that's like the exact opposite of how it is in real life. You need to have you have all your toughest radiation shielding, all of the heavily like reinforced concrete structures that you would need to have for your reactor containment building in place long before you would have a reactor on site. In addition, another really tough material. So concrete is really good at stopping neutrons. Hydrogenous material is good for that, which is in a reactor. And what's good at stopping gamma radiation is lead. So none of these they're not exactly exotic. And yet they're at the far end of the tree. It's just silly. Now maybe that's the goal, that's your end game stuff, since you're trying to survive a crazy nuclear high dose scenario. That's what they put at the end, but it is so crazy. Can you imagine what life would be like if we had nuclear power plants before we had lead?
Or whatever's left of it. I also have the mats to make another heavy shield, but before I get to adding that to my gear, I decide to try and make some elite panels.
Or maybe it's like some ultra-dense super lead that's way more advanced than just lead by itself. Because he did show lead earlier, but either way, it's so silly.
Reaper? Okay, well, you don't need to be a nuclear physicist to know that that's not good.
Yeah, someone suicide bombs your reactor, assuming they even get that close. No. Nuclear power plants in real life have very sophisticated security systems, plus a whole bunch of armed personnel on site to fight the bad guys. So, not saying it's impossible, but security, whether it be physical or cyber security, is very high in a nuclear plant.
When the reactor is compromised, it shuts down, so we don't have a full-on Chernobyl on our hands here.
Well, that's at least something, that the reactor shuts itself down. But to be fair, Chernobyl shut itself down too in real life, because the fuel assemblies have to be placed close together to sustain the fission reaction. But when the reactor exploded and tore itself apart, then yeah, that shut down the reactor. But it just created a really nasty mess and one of the worst radiological hazards of all time. But yeah, it shut down the reactor.
Luckily, the controller didn't get destroyed, and we can shut this all down before it goes critical, and turn this...
Again with the go critical thing. It shut itself down, though, so you're subcritical. You're very subcritical if you don't have enough uranium or plutonium to sustain your reaction. Then there's no way it can go critical in the sense of starting itself back up again.
Chernobyl into a 3-mile island kind of instead.
To a 3-mile island. Well, the thing about 3-mile islands, it had a containment building, so you could pretty much do whatever you wanted to the actual reactor, and everyone would have been fine. I get what he's saying, that though, it being a way lesser version of a nuclear accident.
Wait, do you guys not get the reference there? Trust me, it's better.
I did, buddy. I'm with you.
Weirdly has no frames, kind of naked, I guess. Then it's back to the mines.
Now that's interesting. So hey, it's molten salt, so it's going to have this orangey looking frame. And now there's your idea. Okay, maybe that's why I think molten salt reactors are better, because in this game you actually have a full frame. You have something to confine all the radioactive material. That makes sense. More nukes. I'm actually wondering if the dubstep soundtrack from the nuke is causing more damage than the explosion at this point.
Is exposed directly to the radiation from the surface. And even with my gear protecting me, the rad level is skyrocket.
So that's why you need the shield. Okay, so the whole tech tree is build radiation shields to deflect the nukes. All right, it has a goal in mind. I appreciate that for a video game.
First, fission vessel. This way, the fuel will come in the vent and move through these 2 vessels. Then I place the 3rd vessel and make a default on the side of the other vessels so that it will continue to move to this 3rd one. I'm going to make it then turn by making this side a fuel spread. Did any of that make any sense?
At least they're putting it in some sort of thing that they call a vessel, but It's just funny to me seeing these little arrangement of cubes like it's a nuclear reactor. I mean, I know that's true of everything in Minecraft, but I like it. And hey, you know what? I love any game that draws more attention to using nuclear power for peaceful means. Because hey, here you're the good guy building the reactors and trying to survive the nuclear war. I appreciate this.
An earthquake? Well, I'm from LA. An earthquake should be just fine with me.
Earthquakes. So there are safe shutdown earthquake procedures for nuclear power plants, including what happened to Fukushima. All the reactors safely shut themselves down immediately when the earthquake happened. The challenge and the why it turned into be the disaster that it was all of the sources of shutdown cooling and all the backup sources were destroyed by the tsunami. Now, why do you need shutdown cooling? Well, the fission products, so not the actual fuel, meaning the uranium, the thorium, the plutonium, that stuff is fine, but what it turns into when the fission occurs, those generate heat because they're radioactive. It's decay heat. So you need to keep them cooled with water. Well, the problem is, at Fukushima, again, all their backup diesels were submerged by water, which is a bit ironic because those were supposed to send water to the reactor vessels and the spent fuel pools in order to keep the decay products. And yes, it does exist in a spent fuel pool to have that decay heat. That's why it's in a pool to keep cooled. Granted, there's going to be less decay heat depending on how long the fuel rods were in the spent fuel pool because there's less of it than fresh fuel from a reactor core, but still. But basically during an earthquake, you make sure the reactor is safely shut down and you check for damage and do what you got to do to protect the core.
What's not fine with me is just how hot this reactor is getting. Speaking of which, I'm noticing that my power is really starting to drop off. When I head down to my reactor, I get a small lag spike, and I see that the power is actually disconnected. I'm thinking that the earthquakes might be moving things around slightly in the world, and I'm really gonna have to pay attention to things like this.
It's a shame in this game you don't have an actual control room that tells you like what happened to one of your reactors. I mean, I know that's kind of, I don't know how that would work in Minecraft necessarily to give you a little display screen, but that's typically how you respond to any issue in a power plant in real life is an alarm comes in, and then you in the control room, you dispatch a plant operator to investigate what it is, if it's something that happened out there. But a lot of things you can actually resolve remotely from the control room.
On day 76, I take a minute to think over all of my fuels. The highly enriched fuel is pretty dangerous, and if we get hit by another earthquake, it might be smart to get a more stable fuel.
Highly enriched isn't unstable. Yeah, nothing about it's unstable. It's not gonna detonate, or I would say, so highly enriched uranium is less unstable than gasoline. Gasoline, you have to worry about that thing exploding if you have a spark, but that's not gonna happen with uranium. Really, the thing about highly enriched uranium is it can be used to make nuclear bombs, but in and of itself is not a nuclear bomb. You have to have a conventional explosive, an ignition source, a source of neutrons, and then it has to be started up in a certain precise way. So you have to have already built a bomb, and even then, the bomb's not going to get aggravated from an earthquake to the point where it's going to start its nuclear reaction and ultimately result in a nuclear explosion. It's possible the bomb could be damaged, but it ain't going to go off.
Get us to the MSR. After all, this could be really dangerous if we get hit by a big enough lag spike. Just like that one. At a quarter of a second, wish I couldn't get to the lever.
So lag caused it to basically melt down because it's showing corium of the unholy combination of busted fuel assemblies, fuel cladding, and the reactor vessel. No. Molten salt reactors in particular will shut itself down without the whole Fukushima type issue of it needing that extra water as a coolant. That's one of the advantages of molten salt, and apparently that got taken away in a split second.
Now this. A total reactor meltdown. This corium starts pouring through the cracks of the reactor.
How is he not getting more dose while or is it already maxed out?
I craft up a tank, which soon is going to serve as a hazardous materials barrel. And
there you go. Just scoop it all up and put it in a barrel. Never mind that being exposed to just the heat by itself should kill you. Forget the radiation. But in order to get corium, you're dealing with upwards of 2,000 degrees Celsius.
My buckets to start to collect and store up all of the nuclear waste. Just
maybe heat away exists too. You have heat away and right away, just to to eliminate that.
We are now surrounded by lava and radiation from the bomb.
That's a crazy scenario. I couldn't imagine. Lava. That's not. We don't have an emergency procedure for lava.
I get back to crafting up and repairing the reactor.
Hey, you lucked out, despite the crazy earthquake plus lava plus corium.
So, I'm going to get right back on to start working on those components.
Interesting, MSR means molten salt reactor. MSR actually, in the nuclear plant that I worked at, stands for moisture separator reheater, which splits out a lot of the steam in the secondary non-nuclear part of the plant and extracts it and uses it to preheat the feed water heaters for when the secondary loop goes around and feeds the steam generators, which is heated by the reactor. And it's basically a big make the nuclear power plant more efficiency machine. But it's interesting to see the abbreviation differences.
I'm going to be using MOX fuel again, since the reactor is strong enough to deal with it. In fact, I decided to lock myself in a lab and only...
MOX fuel, that's an interesting idea because what it does is it takes fuel from plutonium that was used in nuclear weapons, and we're essentially going backwards, the opposite of enrichment, to use it as a fuel in nuclear reactors. You don't want to use it by itself, though, because plutonium reacts faster than uranium by a lot, so it can make it a little bit more challenging to control. It also can be a bit more toxic. Not saying it shouldn't be used, just like anything else, it needs to be used in a controlled and safe way.
I then craft up some more sugarcane to make radaway, and I see that it's so red. It doesn't even really look like sugarcane anymore.
So you're putting sugar in your is one of your secret ingredients to make radaway, something that magically gets rid of radiation. If only. That would be so cool if something like that existed. If that was the case, I highly doubt anyone would be as afraid of nuclear, since you just can essentially cure radiation like it's a disease or something.
The only thing that's holding us back is we're going to have to craft up a whole lot of steel. But soon, we can set down our controller. Then, we really start to work on setting out all the framework.
At least he's using actual heat exchangers for this molten salt reactor as opposed to the the one where he just had little cooling bricks that can be controlled, the rate of heat exchange. That's something. And also really cool they incorporated this into the game. I like it.
So we're going to have to get some TBE fuel in the reactor. This might slow us down, but a slowdown is better than a meltdown.
Words to live by and should be incorporated in a lot of pre-job briefings in nuclear plants. I like that. The nuclear version of slow is smooth, smooth is fast.
Okay, next, we make a fluid duct system that will take out all the steam and move it out of the exchange.
And now we're getting into something that actually has a little bit more complexity with reusing the working fluid, heat exchangers. This is cool. I never realized Minecraft could get this complex. It's fun to watch.
You guessed it, a 3x3x5 pattern.
All right, this one's actually going to have a turbine. So now we're getting into like the full scale of a nuclear power plant. I love it.
Must be touching a working beryllium. Then silver, which is the most annoying one of all, it must be touching a gold and magnesium.
All right, now we're getting into him making the generator. Okay, that's cool. I was wondering if they were all going to be little plug-in ones, but hey, having a turbine generator, love it. mean, I guess one difference would be a dynamo is typically direct current versus a generator having an alternator, which makes the alternating current that you typically use to power your house. So you can think of it as a really big nuclear battery. Cool.
With this, I'll be able to keep this vault running for the next 100 years.
Always good to see a project come together. That's really cool.
Big cost for components and the complexity of setting up the MSR system. It also has a pretty in-depth molten salt fuels and the eutectic knack before day 100. Trust me, I tried.
Love the big, like the rat away, the little orange fluid with the radiation symbol on it.
And I got pretty close, but I couldn't quite get it done. So, if you want to see this huge thing come to life, you'll just have to check out my 200 days as a nuclear engineer. Until then, keep surviving.
That was a lot of fun. I especially enjoyed watching the Captain's TV as the guide taking us through this. This was really cool. Like I said, don't know a whole lot about Minecraft, but it is funny to show that they actually have some realistic principles in this game. They have a whole bunch of silliness. Again, I can tell the modder probably wanted to make it more like Fallout than in real life, though maybe a bit of a merger, because there were some things about it that were actually less goofy than Fallout, some things that were more goofy, but hey, for it to go into different reactor types like a molten salt reactor and to bring this in front of people to play around with that, to spark more curiosity so people can learn more about nuclear power, radiation, how molten salt reactors work in real life. I love this mod. Anything to help people along their journey, and also just people who are curious about engineering in general. Thank you very much for watching. I'll see you next time.